Okay, this is the last video that I'm going to do on strategies, and then we're going to get into content. You have 4 days left until the Regents, so I can't stress to you enough how important strategies are when you're taking the test. They're almost as important as knowing the content. Some strategies are going to depend on your content knowledge in order for you to effectively use the strategy. But if you're not using any strategies, you're definitely going to have more problems than if you're not using, than if you are using them. So we're going to talk about multiple choice strategies, some short answer strategies, and as promised, I'm going to go over the short answer keywords, meaning that these exams use the exact same keywords in all short answer questions. And if you're not sure what they mean, what they want you to do when they use them, you're less likely to get credit on the questions. And then we're going to talk a little bit about how to check your own answers against the answer key and see if you're getting it right. A lot of times, one of the main issues that students will have is they can't correct their own work because they're not sure how to figure out if they got the answer right or not. All right, so let's start with multiple choice strategies. Um, there are a number of things I try to tell students to do, and we usually forget when we start to get blindly anxious at the beginning of the test. But one of the most important things that you can do is really take control of the question. You are not there. Uh, let's see, people call this multiple guess instead of multiple choice. You are not there to look through the answers and let the answers push you around. You need to know the material. And often you do know the material and you know that stuff is wrong. But before you start looking through the multiple choice answers, you should know what you're looking for. So, one of my pieces of advice is cover the answers. So, get that piece of scrap paper you're using to read carefully and slow yourself down and cover the answers. You need to start thinking about whether or not you know roughly what the answer is or what reference table you should be looking at before you start looking at the answers. And you should at least be able to identify which topic you're on, because one of the key ways to see if a choice is wrong is to see if it doesn't apply to the topic you're working on. If you sometimes the choices are required for you to figure out the question. I'm going to show you an example of that. But if you're not, if you don't need to look through each answer to actually get the information, you should rely on your knowledge to know what you're looking for before you start looking. So then, after you're sure what you're looking for, you're going to choose an answer that matches with what you know is right. By covering the answers, you're going to slow yourself down, give yourself a chance to actually recall your own knowledge. One of the major issues with these, and they're only going to get worse in the future, is the long answer ones. I'm going to show you a couple examples of questions where they make the answers really long. That gets overwhelming. Immediately, students feel like they're looking at this big, long thing. They don't know how to sort through it all. And so there is a strategy for that. So we're going to do a couple of those. We're going to do three of them, I think. So you're going to first decide on at least one thing you're sure is true. Then you're going to split the choices in half and eliminate options that you know are not correct based off just one half of the answer, not the whole answer. You're also then going to eliminate material not related to the topic. And then that almost always knocks your choices down to at least half. I have had many, many questions where you can knock three answers out using elimination strategies. Okay, so here's a very straightforward multiple choice question. If I cover these answers up and I just look at what the question is asking me for, I notice that there is a keyword which is metallic bonding. I also noticed that there's unnecessary stuff in this question. Whether or not something is at STP, which stands for standard temperature and pressure. Standard temperature and pressure does not determine bonding. It simply determines whether or not particles are close to each other. If particles are close to each other and in the solid state, then yes, we're talking about that they're more bonded than they would be if you separated them. But the type of bonding is not always affected by whether or not you're at standard temperature and pressure. So this is sort of an irrelevant thing that they throw into the question. It doesn't really seem like it's got a point. So the key word here instead is metallic. So you are looking for something metallic. That means you're looking for a metal. So this relies on your fluency on the periodic table. So you should be able to knock out things that are not metals. Remember that if you're dealing with something like, so that knocks out, let's see, first of all, it knocks out argon because it's not a noble, if noble gases are not metallic. The other two confusing things here, barium chloride and sulfur dioxide. Well, sulfur dioxide doesn't contain any metals, so that knocks out 1 and 3. And so you could see right away, we're down to 50-50 shot at this question. I'm going to mark it with you. Right, so I've knocked out 2 answers already. I'm now down to, I've got a 50-50 shot at this. So if I guess, my chances are much better. Barium chloride might sound like it's got a metal in it, maybe it's metallic, but this is ionic bonding because it's in a compound. Metallic bonding happens in pure samples of metal. So typically what they want you to look for is an element off the table you know is a metal. So that's why I'm knocking this one out. When metals are matched with non-metals, they bond ionically, not using metallic bonding. Metallic bonding is a bond between 2 metal atoms. So it's titanium because that's a metal. All right, next question. An element is composed of atoms that must have. Now, this is one of those questions where you don't have a choice. I would say to you, I'll cover up the choices and figure it out. This is actually written so that you have to go through every choice to figure out what is correct. So what I would like you to do is think of these as true-false questions. What you are looking at is something that it must have. So it must be true. It can't be false. So it has to be something that's true about atoms. Do all atoms have the same atomic mass? Absolutely not. One look at the periodic table will tell me that everybody has a different atomic mass. Do they all have to have the same? This is an element, so it's one type of atom. Like if it helps you, make this a specific element. So say all carbon must be composed of atoms that must have. Well, they all have to have the same atomic number because that's the definition. Carbon atoms all have to have the atomic number 6. Okay, do they have to have different numbers of protons? Well, I can knock that out because atomic number is protons. So if you were using this test question as a study guide, this would help you to actually also write down for yourself atomic number is the number of protons. They're the same thing. So they can't have a different number of protons in the same atomic number. That's a big no-no. And their electron number doesn't actually affect what element you're talking about. Elements can lose and gain electrons pretty fluidly and still keep their identity because it's based on their proton number in their nucleus. So this is the only thing in this list that is true about what atoms of the same element must have. They must all have the same number of protons or atomic number. They can't have a different number of protons. Okay, this is an elimination question. And why I'm calling it an elimination question is because you are looking for chemical properties. So for this question, the knowledge you'd have to walk in on is, can you recognize the difference between a chemical and physical property? Okay, so if we're looking for the chemical property, what that means is that there are a number of physical properties in this list. Probably 3 of them are physical properties and 1 of them is chemical. So my new job has just become to find the 3 physical properties in the list and get rid of them. Okay, so what we're going to do is go through this list and find all the things that describe the physical behavior of iron and not the chemical behavior of iron. Okay, so first things first, iron is malleable. Malleable is a property of metals It means that it is flexible, like the way you can bend a paper clip. But if you do that with a piece of plastic, it might snap in half, or a piece of glass. So malleability is a physical property. Iron conducts electricity. That's actually also a physical property. Iron reacts with nitric acid. Now, I think I've said to my students before, this is a dead giveaway. I don't usually use the word reacts with if I'm trying to see if kids know what a chemical reaction is, because it's a chemical properties are properties that elements only demonstrate when they're reacting chemically. So to use the word reacts with is a dead giveaway. And a melting point is a physical property. Okay, so for this one, you did have to know the difference between a physical and a chemical property. This one was actually particularly tough. I think I took this off last June's exam. They usually gives you much easier ones. Like they usually talk about something melting, something boiling, something evaporating, which are all physical changes of state and are pretty easy to pick out as not being chemical change. So we can get a little hint here that they might make the list a little more complicated, but at the same time, they just sort of gave it away because they used the words reacts with. All right, now we get to these ones with the really long answers. And so if these terrify you, here is how you handle them. First thing I'm going to do is, looking at my paper, I'm going to cover up the answers for a sec. And I'm going to see if I can figure out what I should be looking for first. I'm looking for, I'm going to underline this while I'm talking so you could read through it with me. Which phrase describes? Okay, so if you're describing something for me, you're telling me something about what defines it. So essentially, you're telling me its definition. Okay, and the definition is of different isotopes of an element. So essentially, what I'm looking for here is a definition of an isotope. So first, I might want to see if I can remember the definition of an isotope before I start. Okay, isotopes are different versions of atoms where the nucleus composition is different, not in terms of protons, because protons can't be changed. That would change the identity of the element, but only in terms of neutrons. And then changing that neutron number changes the mass of the atom. Okay, and so they're identified by their mass numbers because our mass numbers are different. If you need to review this, I'm going to put, I put in the last one, I'll put that slideshow again. Atoms Revisited is a slideshow I have which goes over isotopes and isotope notation. So that's the definition I'm looking for. So once I've kind of got a feel for what I'm looking for, I know that it involves protons and neutrons. Another way to remind yourself of that is that isotopes, it comes up pretty much when we do the topic of nuclear chemistry. I keep it with that topic because it's one of the times we work with isotopes the most. Isotopes have to do with nuclear chem. Nuclear chem means the nucleus of an atom. The nucleus of an atom only has protons and neutrons in it. So that's something you should definitely know. So I'm going to break these questions down. So here's the strategy. Look at each option. And all of these ones that are really long, this is how they're written usually. Where there is an end, they're going to bring up two different points. There's a point before end and a point after end. So I'm going to look at these one half at a time. I'm not going to read past end. And the reason why is because it's too much. It's going to get me all turned around. So I am going to first eliminate choices that have stuff that have to do nothing to do with the nucleus. So I'm not even going to finish reading it. I'm just going to read this first half. In the first half, you start talking to me about electrons. So that's a no. I'm going to get rid of that. Right? Then I've got protons, neutrons. Right? So now I'm going to go through this first half and see if there's something I can get rid of based off just this first half. If I've got atoms of the same element, do they have to have the same number of neutrons? No. The only thing that has to be the same about two atoms of the same element is that they have to have the same number of protons and the same atomic number. Okay, so I can now get rid of this one. Now I'm down to two. Since these both say the same thing, I'm going to go ahead and figure out what to do with the second half now. So now I'm just going to look at the second half. Do they have a different number of electrons? Well, now I already said that this has nothing to do with electrons. So now I've eliminated all three choices. I now am left with three, the same number of protons and a different number of neutrons. Now, if you happen to have memorized that as the definition of an isotope, good for you. That's great. You would have gotten this. But if not, you might have been able to work your way through it just knowing what you know about atoms. And that's one of the ways that you can do this just using strategy, even if you freeze up and can't remember a definition. I just moved just because I was trying to avoid you hearing the landscaping people in the background at my apartment complex. It's not working. If you can hear them in the background with the blower, I apologize. All right, so here's another one with really long answers. Which change occurs when an electron returns from a high energy state to a low energy state? So first thing I'm going to do before I start worrying about eliminating is I'm going to identify the topic, okay? High energy state versus low energy state. So the topic here is atoms. It is definitely not anything that has to do with ionic compounds forming. Okay, this is atomic structure, and this is when you're talking about energy states of electrons, what you're talking about is excited versus ground state. That is how you produce a spectra. That's what happens when you're flame testing. You're not doing a chemical reaction. What you're doing is just heating something up and letting it cool down and then observing the light it produces. So forming compounds is chemical reactions. So without even looking at the second half of this, as soon as I see that you start talking about compounds being formed, I immediately know that you're lying, right? You're talking about something not related and trying to throw me off. So I'm going to get rid of you. Now I just have to decide between 3 and 4. Am I absorbing energy or am I giving energy off? Well, let me go back and take a look. I'm talking about an electron returning from a higher state to a lower state. So this is giving the energy back. This is when the fun stuff happens. When you give the energy back is when the light is emitted. Okay, so you've got a specific amount of energy being emitted. Now, I want to take a minute here quickly to pause and show you something awesome. Because as I said in my last video, there is a secret to the questions on this exam. Right, this is the core curriculum checklist, core topic checklist, which is what I showed you in the last video, is the secret to knowing what they're going to ask questions about. Now, it doesn't match up exactly with things like what answer I would give in a part 2 question, but if you look, it says topic 1.9 or I.9, when an electron gains a specific amount of energy, the electron's at a higher energy state, excited state. When an electron returns from a higher energy state to a lower energy state, a specific amount of energy is emitted. The emitted energy can be used to identify the element. This is almost verbatim, like meaning word for word, what is in this question, right? So when a change occurs when an electron returns from a higher energy to a lower energy state, a specific amount of energy is emitted. Do you guys see what I'm saying when I say that that checklist basically gives you the answers to the test? Because the question was written based off of one of those target points that is on that list. So using that as the core place where you study the material you're supposed to know, super, super important. All right, let's go to the next question. All right, now these I put down as long answers to break down. And the reason why is because often when students see equations, they just freak out. It's like an automatic way to freak a kid out is just give them a bunch of equations. So let's make some observations before we start freaking out. First things first is these are nuclear equations. These are not regular chemical reactions. So that's the first thing that I need to calm down about, pay attention to. Okay, the reason why is because the notation is very different. When you see stuff written like this is nuclear notation. And nuclear notation gives you the mass number, that's the neutrons plus the protons, and the atomic number, which is just the protons of that isotope. And the reason why it's focused on the neutrons and the protons is because it's nuclear chem, and nuclear chem is focused on the nucleus of an atom. That's why it's called that. And the nucleus of an atom contains the protons and the neutrons. So that explains all this weirdness that you are seeing. Next thing I have to consider is which thing is beta decay, okay? Now, another thing is that this is a great time for you to use table O. Table O will tell you what the symbol of a beta particle is. When something decays by beta decay, it gives off a beta particle, and so you are looking for a beta particle. So if you're using your strategies, you should be able to, even if you're feeling pretty lost right now, eliminate two of these choices because they don't contain any beta particles. And you just told me this was beta decay. Okay? Now, the other part of this is not on the reference table, and it does require your existing knowledge. Oh, I wonder if there's another little cheat code in here. Another little cheat code. Let's take a look and see if there's another little cheat code here. The other cheat code might be, is carbon 14 on the reference table? I would bet you it is. I believe it is on the reference table. I guess I can't leave that annotation. I thought I could leave it there and come back to it while we were doing stuff, but I guess not. All right. Sorry, guys. That was like an amateur move. All right. What if we went over to table N to take a look and see if we could see whether or not these things decayed by beta decay? Oh, look, there it is. It actually is on here. Carbon 14 is on the reference table and it says it decays by beta decay. The only thing that they could do to screw us over here is they might have. Does the other one that we didn't eliminate, rubidium, is rubidium 81 on the reference table? Rubidium 81 is not even on here. All right, so I think a safe bet, just based off of using the reference table and elimination, is that you could say it's 4. And you didn't actually have to know how to write a beta decay equation. Now, in my earlier strategy video, I had said to you, make sure you also work the test, okay? So if you decided that this is the right answer right here, and that you think that this is how you write an equation for beta decay, now if they give you a question somewhere else on the test about beta decay, you will know what the equation should look like. And you should be able to work out using the numbers what if there's like a missing particle you have to fill in what should look like. Now on the downside, I'm going to tell you that part of the magical secret that I gave you, which is that they take everything off the core curriculum list, is that if they've already covered that topic on a question, they will rarely give it to you more than once. So unfortunately, if that's the nuclear decay question, chances are you already did it. You're not going to see it again on the part twos. But there is often a big chunk of part 2 questions on nuclear, particularly toward the end of the test. So let's not count it out. All right, this is a really long question with nuclear chem. They give you two equations, equations A and B, right? So if your brain is already shutting down because you're like, oh my God, this is so long, it's so many things. Why does it have to be so many things? Start covering things up with paper and just take it one thing at a time. Also, don't forget your anxiety strategies. Don't do this question right now. If you've got an easier question you could do, and this one is you want to spend your time at the end doing this rather than stressing yourself out right now, and you already have target topics that you're going to do that you think you're going to get points on, circle it and come back to it. And then right before you transfer all your answers over, you're going to take a deep breath, cover this with a piece of scrap paper, and you're going to do it one thing at a time. Okay, first I'm going to look at the question before I go back to the gobbledygook equations and figure out what it is that they're trying to ask me. First of all, they want me to figure out which type of nuclear reaction both of these equations represent. Okay, and so if I look at the choices very quickly without trying to commit to anything, I can see that it's between fission and fusion. So I'm going to want to look at them and see if I can remember, what does fission look like? What does fusion look like? Now, just going to vocabulary, fusion means to come together. And in nuclear chem, it is when two lighter elements combine to form a heavier element. And fission is when you split something apart. And in nuclear chem, that is when you approach the nucleus of an atom with a neutron, try to add that neutron to the nucleus, which destabilizes the nucleus and essentially causes it to fall apart. And when it falls apart, all of the pieces go flying everywhere and hit other atoms and start a chain reaction. So fission means to split up, and the mechanism for splitting it up is adding a neutron. So if I look at the patterns here, first of all, I have two very different patterns. I have a pattern here where I'm adding two things together and I'm getting a bigger element. Two hydrogens makes a helium. That's a heavier element. Here, I have a pattern where I have a humongous element, uranium-235. It's getting sort of hit with a neutron, and then it's breaking up into smaller pieces. I have a lot more pieces over here, right? So I don't think there's only one type of reaction here. So that eliminates choices 1 and 2, because 1 and 2 are implying that I have only one type of reaction. And to me, it looks like two different things are going on here. Okay, so now I just have to figure out, is A fission and is B fission, right? So I said these two are coming together to make a heavier element. Neutron, not an element, it's just sort of like a leftover particle. So this is fusion. I'm combining. This is classic fusion. If you remember this from Earth science, this is what happens in stars. Most bright, white, beautiful, or blue, beautiful, brand new baby stars are doing this for millions of years, however long they live. I don't know, I'm not an Earth science teacher. They are burning hydrogen mostly in the beginning. It's not until they get much older that they start to burn heavier elements and make heavier elements until they finally go supernova on you. It takes a long time, don't worry about it. So you've got a whole bunch of hydrogen making helium. That's a classic fusion reaction. And here you've got uranium-235 splitting into smaller pieces. So this is fission. So this is A is fusion, B is fission. Now, these are also classic examples of these. If you're looking for a way to be able to recognize fission and fusion quickly, these would be at the top of my list. You're looking at either big, big elements like uranium or plutonium being hit with things and split, or really, really baby tiny elements like hydrogen, helium, maybe even lithium, really little elements coming together to make bigger elements. You're going to see that in fusion. All right, now on to the short answer strategy. So I'm not going to take too long on this section because I'm going to be using the strategies while I'm doing short answer questions in each of the topic videos. So I just said we only have 4 days left. I'm going to cram you through some of the topics that will get you the most points. I'm going to focus on part twos and trying to get you as much as I can, help and strategies as I can on part twos. Most kids actually do pretty okay on the multiple choice. Like I said in the first video, you need 52 points to pass. So if of that 52 points, if you can get, 30, 40 multiple choice questions, you don't need that much of the short answer section, but you do need at least a third of it to a half of it. So you don't want to go in there leaving half the short answer questions blank. You want to try and hit as many of them as you can to get points, but you definitely want to have core topics that we're going to go over in the core topic videos. And I'm going to start those today and try and get them up for you as quickly as possible. Okay, so here's what I see when I see kids answer short answer questions. And they're not just my students. I score all the other Regents exams with the other teachers. And so for the last almost decade now, I've been looking at the short answer answers that people give on science exams. And they do a number of things that are insane. But some of the errors that really I see the most and that really break my heart. The very top one is you give me correct information. Sometimes not about the right topic, but sometimes it's about the actual topic. You give me correct information, but you don't answer the question they asked you. And so on my tests, I mark this with a mysterious 4 letters that my students are always like, what is this? I say this. So the reason it breaks my heart is because you gave me correct information about the topic, which means you know it. You know the chemistry, but the question that was asked, you did not answer. So this stands for question asked, not answered. You don't want to do that. You can't just ignore what they asked you. The test is written in a very specific way. They want a very specific answer to award you that point. The questions have been written that way on purpose in order to make it first reasonable for the student, so they only have to hit a very narrow target, and reasonable for the person who has to score it. I should know how much wiggle room I have on accepting that answer. So if I have you've asked the question a very specific way, then I know exactly what kind of answer I should be looking for. Okay. Another critical mistake my kids make is they over explain things. Okay. If you had the right answer and then you decided to write a whole nother sentence, in that sentence, you wandered off topic and started to say crazy things like that atoms pick up positive charges when they lose electrons. Oh, no, that's correct. Atoms pick up positive charges when they gain electrons, or their radius increases when they lose electrons. Now you've not only given me incorrect information, you've made me doubt whether or not you know what you're talking about because you've gone off and rambled about something else and said something that was actually incorrect. So you over explained. Hit the target and move on. Okay, so make sure you answer the question and then don't keep explaining. This is not a Regents where you can do that. I don't want to curse again by accident in another video, but essentially making stuff up, BSing like you would on an essay question to try and write more and see if you could get more points. It's not going to work on a Chem Regents. There are very specific answers to these questions, and you should not go off onto some sort of side conversation. Okay. The last one is don't write too much. You do not need to restate the question. You need to answer the question correctly. Okay. So restating questions is mostly a waste of your time. The more time you waste on a question, the less time you have to answer another question. That goes for doing calculations you were not asked to do. So if a question says do a numerical setup, don't answer the question. Do the numerical setup, don't solve it. If you have to get a calculator out and solve a math equation that no one asked you for and no one's going to give you points for, if you solve it and put the answer, you don't get a point for that. You don't get any partial credit for that. Okay, there is no partial credit on a Chem Regents. So you get 1 point for each question. That is it. Either you nailed it or you didn't. So if writing more does not make your answer more correct. In fact, it's kind of dangerous to do. Okay, so these are things you do not want to do on short answer questions. So let's talk a little bit about the actual very specific language they use on these questions. If they say the word state, that means just tell them what the answer is, right? So if it says state the ion that is in hydrochloric acid, the answer is hydronium or H plus. That's it. There's no explanation. Don't write a sentence. That's the answer. Okay. If it says determine or calculate, they often say determine. They want you to do solve for something, but they're not going to grade you on your work. So your work does not have to be shown and it doesn't earn you any points. So go in your test booklet and do out whatever work you can do. Whatever answer you get, that's what you're going to write in your answer booklet. If you're right and you did it wrong, you still get the point. So don't show them the work, which is going to make the teacher doubt if you got it right. You know, we're not grading your work. So technically I can give you the point even if you did it the wrong way, but you just don't want to do anything that calls your answer into question. Okay, identify. Identify typically means find something and tell them what it is. So sometimes they'll say identify on the data table the data that supports this. You're going to pull that data off the data table and write it as your answer. Identify does not, there's no thought involved in this. Okay. Identify is a little bit like state, but usually relies on information that is in the question. So, for example, if it's a passage, they might say, identify the element that makes a green light when you're burning fireworks. You just have to go through the passage and look for that, and it'll be like beryllium, and you're going to just put beryllium. There's no sentences, no explanation. Unless the word explain is in the answer, do not explain. Okay, an interval. I'm going to give you an example of what an interval looks like. An interval is a range, usually of numbers. So if it says a time interval, it's going to be like 3 seconds to 5 seconds. You're going to usually be reading it off a graph or a data table. Typically, these are graph questions, and I'll tell you right now, they're usually heating and cooling curves. Um, so it will say in the time between 3 and 5 minutes, what's happening, or during what interval is this substance melting? And you just have to read that off. You're giving them a time range. So 3 to 5. Okay. Make sure you pay attention. If they don't ask you for an interval, they may be asking you for something else. It could also be letters. If it's a graph where they have no times, but they put like on the curve, they put A to B, and then on the heating and cooling curve, you could see that's when it's melting. You're going to put the interval as AB. Okay, it really just depends on how they ask the question. But for some reason, I have a lot of kids who don't know what an interval is. I've had kids give me a temperature. A temperature is not an interval, it's a temperature. So if they ask for a temperature, just give them a temperature. All right, now you can explain, except there's still an exception to the rule here. If it says explain on the old Regents, this is the old Regents you're taking, they actually don't really want you to explain. Do you know why you're not going to explain? Because you're not a quantum physicist. You can't explain, why electrons move as waves or why electrons go up and down in energy level and release light. There's no way for you to do that. It is beyond the capacity of your abilities at this point. So what they're asking you really to do is give known information or a definition that supports the conclusion that they've already stated in the question. So later when we go into these, I'll give you an opportunity. I'll have an opportunity to give you information about how kids mess this up. Often in the question, they will already tell you what you're explaining. So they will say, the atom is going to give off light. Explain why. Don't in your answer say the atom's going to give off light. Yeah, they already said that in the question. So you're just restating the question at that point. It's like 100% the best way to never get a point for anything. It looks to us like you just don't know what you're doing and you're copying the questions into the booklet so you can get out of the test. So explain means give a known definition or rule that supports the conclusion stated in the question, but you're not coming up with your own explanation. That is beyond your abilities at this point in your chemistry career. Okay. You are explaining something from your existing knowledge that you've learned. Okay. Now, this is the most important phrase on the test, I sometimes think. I'm going to do what my kids know I do. In terms of. If a question says in terms of, that means that's what you're discussing in the question. If you don't discuss it in the question's wrong. So you must address whatever comes after that phrase. If you don't mention it in your answer, there's a very good chance you got the question wrong. Okay, now the opposite is also true. You can't just mention it, but then also get the question wrong because you didn't answer the question. Just mentioning it doesn't make the question right, but omitting it does make the question wrong. So this is, you're walking a thin line here. Show numerical setup, as I mentioned earlier, means plug in the numbers and show the algebra. Like, so if you're using a formula, plug all the numbers into the formula, show the setup, but then stop. You are not solving. You do not need to do any more algebra than that. They just want to see if you can appropriately set up how to solve that question. Okay. If you sit there and solve it, you're not getting any points for that. You're not getting any credit for that, and you are wasting test time. So please don't solve. But please do make sure you check to see whether or not you're supposed to set it up or solve. Because if you only set it up and don't put the answer and you were supposed to just determine the answer and not show the setup, then you're going to get it wrong. Okay, if you put the answer, it's not getting graded. So it's really a waste of your time if you solve it. But a lot of people still, even though I've gone over this hundreds of times, I feel like will still freeze on this question and think that they can just write the formula. No, the word numerical means that you have to plug the numbers into the formula. That's what that word means. And you have to set the problem up like you're going to solve it. You're just not going to solve it. Okay. Sometimes they'll do these as multiple choice questions, and instead of you setting it up, they'll have you pick the correct setup out of the multiple choice. So that you have to watch out for, because sometimes they will partially do the algebra and that can change the way it looks. All right, compare. In compare questions, you do want to compare one thing to the other. The safest way to answer these is to state both things in the answer and make sure that you state it. I've had kids just say, it's higher. If you don't tell me what's higher than the other thing, the question, your answer is invalid, because I don't know what you're referring to, so I have no idea if you know what you're talking about or not. Okay, so you have to say the ionization energy is higher, or the ionization energy is higher as you go down the group, or the ionization is higher as you energy is higher as you increase in atomic number. You can say more, but don't say too little that you don't get it right. You do have to state what it is that you're talking about. Sometimes you can get away with it if they say based off how they phrase the question, but don't chance it. Your best bet is to say, the density of the liquid is higher than the density of the gas. This is kind of one of the only times when you're doing explanations or compare, is the only time really when you should be writing almost full sentences or maybe more than one full sentence. But you're going to see when you look at the answer key in the later videos with me, they really don't want that. Actually, we're going to look at some answer key excerpts now. All right, the last thing that I want to go over is how to check your own answers. You're probably not going to be able to sit through every single video of me going over this. And I know my voice is just so darn soothing that you're falling asleep right now. But how do you use the answer key to figure out if you're getting it right? And how do you check your answers when you don't have an answer key and you're taking the test? So the first thing is that these keywords are a huge part of seeing if you're getting the answer right, right? If you are checking to see if you nailed it, you have to make sure, like if you were supposed to have an interval and you didn't write both numbers of because an interval is a range. It goes from a starting number to a finishing number. If you didn't give me a full range, you only wrote one number. Checking that key word is a way for you to see if you did it right and then fix your answer. But while you're studying, you're also going to want to make sure you use that rating guide to see if you would have got the credit. So I'm going to show you quickly how to do that. And then you really need to look at those answer keys and practice trying to see if you hit the mark. Did you over deliver? Did you under deliver? Are you giving too much unnecessary information? Is there something they've mentioned in all four of their versions of the answer that you didn't talk about at all? So let's go over one that happened when I gave my final this year. These are two different questions. Notice anything interesting about them? They're pretty much the same question. This is from June 2016, June 2024. They are recycling these questions pretty hardcore at this point. And the reason why is because even back in 2016, they knew at some point they were not going to be using this test anymore, because we were supposed to be moving over to a test that more reflected next generation science standards. We'll get into an argument over whether or not that's true in another video, maybe. But in this video, let's just talk about that they gave us all the same questions. This is why this year is going to be such a great Regents for you guys, because if you've studied between 2 and 4 Regents exams really well and you're practicing a lot, nothing on this test is going to be a surprise to you. I really hope. They're not going to be testing out new questions and stuff because there's not going to be a new test. So state, both of them say state, which means get right to the point. It doesn't say explain, it says state. Get right to the point of explaining to me how a known element can be used to identify an unknown element. Now, notice that one thing that was different about these two questions. In the old question, they said, state how bright line spectra viewed through a spectroscope can be used to identify an element. And then in the later ones, they actually gave you more help. They specified known and unknown in the question. And the reason why was because they wanted you to talk about it. So in a state question, you are going to restate a little bit. You're not going to restate the question. You're going to borrow their words and make sure you use them. So by using the term known and unknown, essentially what they're saying to you is you need to use those words in your answer. And the reason why they're saying state instead of explain is they don't want you constructing any really unique sentences here. So let's look at a student's answer that was considered kind of correct in June 2016 and was considered wrong in June 2024. This was very close to what I got as an answer on my final. So a lot of people just wrote each element produces a specific set of spectral lines. Some people said a unique spectral line. Some people said specific colors. The problem with their answer, and the reason I couldn't give them credit, was because the question specified that they had to use a known spectra to identify an unknown spectra. These newer questions to me feel like non-questions. In other words, they're not asking you very much. They're almost telling you what to say, and you just have to be able to say it back to them. And if you're not a great reader and you haven't practiced these strategies, you're not going to do that. You're going to sit there and freak out and put some nonsense down, and then they're going to be able to mark you wrong. They basically told you that you use known elements to identify unknown elements. They put it right in the question. And yet my students didn't say it. The fact that each element produces a specific, unique spectra is absolutely the reason we can use them to identify other elements, but you still have to match a known sample with an unknown sample, which is what we do in lab, right? So let's look at the answer key, and I'm going to show you the answer key from both years. So in 2016, they took, I don't know, all of theirs actually said the same thing that it said in 2024, but I think they were a little bit less clear about what they wanted when they wrote that question. So I think they just spruced it up a little when they redid it last summer. So acceptable responses include, but are not limited to, means that I do have, the teacher who grades your exam does have the right to kind of interpret, or usually what we do, more than one person grades your exam. So what we do is we kind of throw it out to the room and we say, would we take this? Or a lot of times as a district, all of the chemistry teachers get on the phone with each other and we say, what would we take for this answer? We do something called norm the answers. And then if we all agree, a whole school district's worth of teachers or a whole room of science teachers, we all agree that that's not going to cut it, then we don't take that answer. So you want to be really careful. But you have all these choices, right? So like, let's get the 2024 one was a lot more specific. Does your answer need to be this long? No. There were many shorter answers. But notice when you're checking your answers, what's the critical thing you had to hit? In every single one of these, they used the words unknown and known to describe that you had to compare two samples. That without a reference sample, a known sample, there was no way for you to know what that element is. And that's a pretty common theme in chemistry. Okay, so they do have some more kind of open-ended ones towards the end, but notice here that they didn't use the word known unknown, but they used the word match, right? And here they use the word find. You'd have to find another one with the same wavelengths as the unknown element. This is not the best answer though, because this one implies that you also don't know what the other element is. Um, so I hope I'm nailing this home. When you're looking at the answer keys and practicing part two questions, there's going to be ones that it's easy for you to figure out if you're right and wrong. Ones, let's say things like state or identify, but or numerical setup. It's going to be a lot harder for you to interpret ones where you have to look at a long list of answers. Try and figure out what's in common about all four of the answers that they accepted. And if your answer doesn't have it, you need to really consider why you omitted that. If you realized it, if you knew it or not, chances are if you wrote something that was in the ballpark but just sort of missed it, you do realize it. You're just not saying what you mean. Remember, this is a written answer. I'm not a mind reader. I can't figure out what you're implying. So you really do have to be clear, but you don't have to write so much that you start to say things that are wrong. All right, that wraps up this video. So I'm going to go start making the first topic video right after this gets all uploaded, and I'm going to time index it so that you don't have to listen to me talk so much. I'll see you at the next video.